Welcome to Programming News Daily. For July 18, 2026, we're looking at why your AI subscription might be turning into a variable utility bill and how new projects in the RISC-V and X11 ecosystems are trying to redefine how hardware and displays actually start up. We begin with the economics of artificial intelligence. For much of the last 2 years, the primary way organizations consumed AI was through predictable, flat-rate subscriptions. But new research from Forrester suggests that model is shifting. According to a survey of over 2,600 decision-makers, 80% of respondents expect their software budgets to rise next year as vendors move toward usage-based billing to pass the massive costs of AI infrastructure directly to the consumer. We are already seeing this play out in the market. Companies like OpenAI, Anthropic, and GitHub have begun shifting various services toward these consumption-based models. Even Microsoft has introduced new licensing options, such as the premium E7 license, which bundles Copilot and other tools into a different pricing structure. This transition creates a significant new headache for engineering and finance teams. Instead of simple, predictable monthly fees, organizations are now facing the reality of variable costs that fluctuate based on how many tokens a user or an agent consumes. To manage this, the industry is seeing the rise of a new specialized discipline within FinOps. Engineering leaders are having to implement runtime controls to prevent runaway cloud bills. This includes things like model routing, where an application decides which model to use based on cost and complexity, and semantic caching, which stores and reuses previous AI responses to avoid redundant processing. There are also discussions around implementing usage guardrails to ensure a single runaway loop doesn't exhaust a quarterly budget in a single afternoon. While some tech giants have been announcing layoffs recently, the data shows that IT staffing spend isn't actually declining. In fact, 67% of decision-makers expect to increase their staffing budgets through 2027, with a specific emphasis on roles dedicated to data and analytics. The takeaway from the research is that as AI moves from a novelty to a core utility, the organizations that succeed will be those that build robust foundations, specifically regarding trusted data and strong governance, to manage these increasingly unpredictable costs. While the high-level economic landscape is shifting, there is also significant movement happening at the very bottom of the computing stack, particularly within the RISC-V ecosystem. Currently, booting different RISC-V hardware can be a fragmented and complex process, often requiring custom configurations for every single board. To solve this, Yuri Zaporozets has proposed the Harmonic Firmware Initiative, or HFI. The goal is to provide a standardized, BIOS-like experience for RISC-V hardware. It is important to note that HFI isn't intended to replace existing bootloaders like U-Boot. Instead, it's designed to work alongside them. The firmware would act as an early-stage interface that identifies the system, lists connected peripherals, and offers a setup program before handing control over to the operating system loader. And one of the most practical aspects of this initiative is a video BIOS designed to initialize arbitrary video hardware in a standard way, bringing the system up to a VGA-like text mode. We've already seen a successful demonstration of this on a C555 unmatched motherboard. Using an NVIDIA graphics card, developers were able to show a text-based boot-up display without using any x86-specific BIOS code. If this initiative, which is being stewarded by QSOE Systems, gains widespread adoption, it could offer a much simpler alternative to the complex EDAT UEFI implementation and make it significantly easier to move software across different RISC-V hardware platforms. This push for low-level standardization in RISC-V mirrors a different, more radical trend happening in the Linux desktop space. While Wayland has become the dominant standard for Linux display servers, there is a surprising renaissance of experimental X11 and alternative display projects emerging from the system's programming community. One of the most striking examples is a project called Frame. Developed by Gear Izine, Frame is a hyper-minimalist X11 server implemented entirely in x86-64 assembly. It is part of a broader effort known as the Chasm Stack, which aims to create a complete, standalone software stack, including a window manager, a terminal emulator, and a shell, all as independent binaries with no external dependencies. It's a pursuit of extreme minimalism that stands in stark contrast to the massive complexity of modern desktop environments. Other developers are taking different approaches to the same problem of display complexity. Josta Hayes is working on Iserver, a Rust-based implementation that supports a wide range of environments including XFC. Meanwhile, the Archon display server is pushing boundaries with its A12 protocol and a module called Waybridge, which allows Wayland applications to run alongside it, while also allowing shell commands to integrate graphical media directly into the terminal. These projects represent a fascinating tension in systems engineering. On one hand, the industry is moving toward the standardized, unified model of Wayland. On the other hand, there is a persistent, highly specialized push to build new, high-performance, or ultra-minimalist display protocols from the ground up using low-level languages like assembly and Rust. Whether these niche projects will find a permanent home in the mainstream, or if they will remain specialized tools for high-performance or embedded workflows, remains to be seen. Whether it's managing unpredictable AI token costs or standardizing how a RISC-V board boots, the common thread across these developments is a push for better control over the underlying layers of our computing stack.